Periodic properties, origins of the periodic table. Lavoisier's law of conservation of matter and Proust's law of constant composition, also known as the law of definite proportions, led to Dalton's atomic theory. As chemists began isolating elements and characterizing their compounds, Stanislaw Cannizzaro came up with an accurate list of atomic masses, allowing for much greater consistency in chemistry. As elements were characterized by their physical and chemical properties, it became clear that many elements share properties. For example, sodium, potassium, and rubidium are all soft silver metals that react vigorously, even violently, with water. Fluorine, chlorine, bromine, and iodine are gases or very volatile liquids or solids, meaning they go easily into the gaseous state, which react violently with sodium, potassium, or rubidium. As more elements were discovered and characterized, scientists began finding patterns or trends in the elements as mass increased. But it wasn't until Dmitri Mendeleev proposed his table of elements in 1869 that a consistent pattern emerged. Our modern periodic table came out of Mendeleev's original table. Mendeleev started by listing the elements in order of mass, then observing that certain properties repeated as he looked along the list. The properties were periodic. He arranged the elements with similar properties in columns. As you look along the rows, the elements increase in mass. As you look down the columns, elements share similar physical and chemical properties. Although Mendeleev started with the elements in mass order, he found that the pattern didn't always work correctly unless occasionally a slightly heavier element was placed before a lighter one. Mendeleev also found that he needed to leave several blank spots in his table to get the elements to fall into columns correctly. He predicted that new elements would be discovered that would fit in those spaces, and he predicted some of their chemical and physical properties. The element gallium was discovered 4 years after Mendeleev's prediction, with characteristics just as predicted. Germanium was not discovered until nearly 2 decades later, but it also has characteristics as predicted by Mendeleev.